beginning, I told that there are several methods to solve linear programming problems. Graphical method, then simplex method. Simplex method is an analytical method. Some mathematical techniques are used there. Then using computer software, there are many computer software that can be used to solve operational research problems, linear programming problems. Then there is another method called graphical method. Graphical method we can use to solve linear programming problems with two variables. If we have two variables, we can use the graphical method to solve linear programming problems. In the today's class, I am going to teach the graphical method that can be used to solve linear programming problems. So we will see step by step how we can use graphical method to solve linear programming problems. Okay, so let us consider this example. This is a maximization problem. We want to maximize 2x plus 4y subjected to, there are three constraints. X plus 3y less than or equal to 12, 2x plus 5 less than or equal to 16, 5x plus 9y less than or equal to 45. Now, in this particular problem, we have two variables. So as I told you, when we have two variables, we can use graphical method to solve the problem. So in the graphical method, what we have to do is we have to draw a graph, and based on the graph, we can find the solution. So that is graphical method. If we want to use the graphical method, in fact, we have to have some graph sheets or graph papers so that we can accurately draw the graph. So if not also, you can draw the graph into a rough scale and find the answer. So the basic steps of the graphical methods, we have to draw all the constraints in the same plane and identify the feasible region. So I will explain what is the meaning of that. Before that, I want to summarize the method here. Here we have constraints. These constraints we have to draw in a Cartesian plane. So in the graph, we have to draw these constraints. There are three constraints. All three constraints should be drawn in the same plane. But here, the problem is that these constraints contains inequalities, not equal signs. For example, this is first constraint. If we had an equal sign, so that means x plus 3y equal 12, then we can easily draw it in a Cartesian plane. But here now we have less than or equal sign, so that means this is an inequality. So you have to recall the memory that how you can draw an inequality in a graph plane. So we can draw. So we can draw an inequality in a graph sheet. And the same graph, you have to draw the other two inequalities also. Okay. So you have to draw all three inequalities in the same plane. And also there is another condition that this x and y should be greater than or equal 0. That also can be considered. So we have to consider that one also. Then the problem is how we can draw these inequalities in the graph. Okay, so first we have to forget about this inequality part, and we have to draw the lines. Okay. Now for example, for the first constraint, we have this x plus 3y less than or equal to 12. So to draw this, you have to first forget about this inequality part and draw this line x plus 3y is equal to 12. So that you can easily draw in the graph. So how to draw that line? To draw a line, we should know at least two coordinates on that line. If we know two coordinates, we can mark them on the Cartesian plane and join by a straight line, because we know that when we say x plus 3y is equal to 12, that is a linear equation. Because the power of the variables are 1, we have two variables, we can write this equation in the form of y is equal to mx plus c. So that is the standard format of a straight line. So when we say x plus 3y is equal to 12, then that is a straight line. So what we can do is we can find two coordinates of this equation and mark in the Cartesian plane and be joined by a straight line. Then we can draw the equation of x plus 3y is equal to 12. Then the problem is how we can find two coordinates. How we can find two coordinates for this first one, x plus 3y is equal.
lagi interlude දුන්නා.
කල්පනි good morning.
Good morning.
ආවනේ දිවට
මොවනේ මත එකක් කතා කරේ.
අනේ අපිට නම් එපා.
මේ මොනවාද ක්ලාස් එකක් මේකයි කුප්පියක් නෙමෙයි.
මේ කී දෙනෙක් ඉන්නවද 43ක් ඉන්නවා මේ තේ 43ක් හදන්න. T 50ක්.
නැගිටින්න දැන්ද කොහෙද මට
T 50ක් හදන්න.
කුසල්ල තමයි වෙන්නේ කුසලුයි ශාමිලේ වෙන්නේ.
එනවද?
කුසල්ලින්
ඔගොල්ලෝ
Okay, so we'll restart. Sorry for the problem occurred due to our failure. So we'll quickly do one example. Uh, so this was the example that I was talking about. Let me properly share this first. Okay, can someone confirm that you can see the screen?
Yes.
Okay.
Okay, so as I explained you, we have to draw all the constraints in the graph. To do that, I will first explain how to draw the first constraint, x plus 3y less than or equals to 12. Okay, so what we can do is we can just forget about this unequal sign first, and first we draw the line x plus 3y is equal to 12. So when we do that, in order to draw a straight line, we should know at least two coordinates on that line. So two coordinates, if we know two coordinates, what we can do that we can plot in the graph and we can join 2 points by a straight line. Then we have the equation of that line. Okay. Now then the problem is how to find 2 points. So if you want to find two coordinates, so the given equation, what you can do is that you can substitute some variable. For example, we have x plus 3y is equal to 12. That is the equation. So you can substitute x equals 1. Then if you substitute x equal 1, you can easily find the y value corresponding to x equal 1. Then you have one coordinate. So 1 and the corresponding y value. Then if you want to find another coordinate, you can substitute another value for x. So you can substitute any value. For example, you can substitute x equal 5. Then we will have a corresponding y value, and that is the other coordinate. So we will have two coordinates. So you can find any number of coordinates by substituting values to variable. So not only for the variable x, if you want, you can substitute for variable y. Then you will get the corresponding x value. Then you will have coordinates of a point. Okay, then if I take x plus 3y is equal to 12, when we substitute values, the easiest value is to substitute 0 for one variable. Substitute 0 for one variable. Then what will happen if we substitute x equals 0 in this equation? So this part now 0, then 3y is equal to 12. If 3y is equal to 12, we know that when we divide by 3, y is equal to 4. Okay, when x is equal to 0, y is equal to 4. Then 0, 4 is one coordinate. 0, 4 is one coordinate. So you don't have to substitute 0, you can substitute any value, but the easiest way is to substitute 0 for one variable. Then you can do the
Recording
same
in
for the other
progress.
variable also. Next time you can substitute y is equal to 0. So when you substitute y is equal to 0, what happens? X becomes 12, then 12, 0 is another coordinate. So 12, 0 is another coordinate. Then we have two coordinates, 0, 4 and 12, 0. Then what you can do is you can mark these 2 points on your Cartesian plane. You can mark 0, 4 and you can mark 12, 0. And after that, you can connect these 2 points by a straight line. Then you will have the equation of x plus 3y is equal to 12. So now still I am talking about this equation part, not the inequality. Then similarly, for the other coordinates also, you can find a set of coordinates like this. For the second one is x plus y is equal to 16. X plus y is equal to 16, then what will happen? This is the equation x plus y is equal to 16. then we'll put x equals 0. When we put x equals 0, y becomes 16. So 0, 16 is 1 point. Then we'll put y is equal to 0. Then what will happen? 2x 16, x 8. So 8, 0 is another coordinate. So these are 2 points on this line. So you can substitute any value, but I am referring to the easiest method. So you substitute 0 for one variable, and next time you substitute 0 for the other variable. Then you can easily find two values. And the third one, the third equation, this one, 5x plus 9y 45. Again, you can substitute x equals 0. Then 9y 45 means y is equal to 5. Okay, so 0, 5 is 1 point. Then next time y is equal to 0. If y is equal to 0, 5x 45, therefore x equal 9. So 9, 0 is another point. So we can find coordinates like that. Now for all three equations, we know set of coordinates. All three equations, we know set of coordinates. Now we can mark them on a Cartesian plane and we can draw three lines. Now, according to our question, we know that we have a condition that xy is positive. Therefore, when we mark, this is the xy plane that we are using. But according to our question, we know that x positive, y positive. So both x and y are positive. Our graph should be on this area only, because this is the only area that both variables have positive values. Now in this place, we have y positive but x negative. Now here, what will happen? X positive, y negative, and this part both variables are negative. So this is the only part we have both variables are positive. Therefore, when we consider x greater than 0 and y greater than 0, we can draw the graph only in this area. So we don't have to use the other three quadrants. We can use this part to draw the graph. Okay, so now this is the Cartesian plane. So I have marked the coordinates. Now the first one I have marked 0, 4. Then 12, 0. 0, 4, 12, 0. Then next one 0, 16, 8, 0. So we can connect 0, 4 coordinate with 12, 0. Then 0, 16 with 8, 0. And the last one 0, 5 and 9, 0. So we can draw that. Now this is the first one. Now this line corresponding to the constraint 3. The constraint 3 means we had 5x plus 9y less than or equal to 45. You remember the equation. And without that inequality part, this is the line representing 5x plus 9y equal to 5. Then the thing is, we have to mark this less than side on this line. So how to mark the less than sign? So this is the way you mark an inequality. So the less than side, you have to shade this. So this is the less than side. This is for the third constraint. Now for the second constraint, so I will later explain how you find the less than side, because less than side is always not the lower side. Now some people think that if it is the less than side, you can shade this lower side, and the right hand, when it comes to greater than, some people always mark the upper side from the line. So that is wrong. So you have to first find out which side is less than side and which side is greater than side. Okay, so after example, I will explain further how to find that. But for the time being, this is the less than side for the third constraint. Now the second one, we can draw the line in this way, and if we shade the less than side, it's like this. Now these are inequalities, not the equations. Okay. Now, if I consider this part, this is the graph of the equation because no side have been shaded. But when I shade this one, this becomes the graph of the inequality. Graph of the inequality. Now these are for the third constraint and the second constraint. For the first constraint, if we draw the line like this, then when we shade, we will have the inequality like this. Okay, so what I want to do is you can draw this line, not line, this graph roughly, because there are certain things I want to have some notes. Therefore, please quickly make a rough chart and mark these 3 lines. Then later I will explain how we can use this graph to find the solution to our problem. Okay, just take 1-2 minutes and draw this graph on a piece of paper. So you don't have to use the exact scale, but roughly draw this and mark these inequalities also. Then I will further explain what you can do with this. So at the same time, if you have any question, you can ask. Okay, now if you see this graph, you can see that there is a common area to all three inequalities. Now, inequalities in the sense that we have shaded some areas. So, if you properly shade, you can see that there is a common area to all the constraints or all the inequalities. That common area is this area, because this area is covered by all the shaded parts. This area is called a special name. This is called the feasibility region or solution space. Feasibility region, or we can say feasible region or solution space. Why we call this solution space or feasible region? Now we know that. Let's go back to the question. So this is the question. Now the meaning of these constraints, we have set of constraints. When we find the solution for x and y should satisfy all these conditions. X plus 3y is less than or equal to 12. So that means, let's say for example, we like to have a solution x is equal to 5 and y is equal to 5. If our solution is x is equal to 5 and y is equal to 12, what will happen? The first constraint less than it should be less than 12. If we consider the left hand side, x plus 3y. If I take 5 for both variables, 5 plus 3 times 5, that is 20. So that x is equal to 5 and y is equal to 5 does not satisfy this constraint, because left hand side become more than 12. Therefore, that is not a possible solution. So our solution must satisfy all three constraints. That is the meaning. That is why we are indicating these constraints, and we say subject to these constraints. Now, sub-constraint means our solution should satisfy all these constraints. So let's go back to the graph, and this is the feasible region. This feasible region covers the common area for all inequalities. So that means if we find any point from this shaded area that satisfy all the constraints or all the inequalities. If we find some point from this shaded area that satisfy all the inequalities. Now, on the other hand, let's say, for example, I take some point from this area. Okay, I take some point from this area. Then what will happen? This point is covered only by this inequality. Okay, when we shade the less than side here, it is covered only by this inequality, but for the other two, that is not satisfied. Therefore, this is not a solution for this problem. If we find this x and y points here, so approximately x equal to and y is equal to 7, it is not a solution, because it covered only by the second constraint. Therefore, if we want to have a solution, it must be in a common space. It must be in a common space. That common space is this one. That is why we call it feasible region. That is why we call this feasible region or solution space. our solution must be here. We don't know where it is, but it must be in this area. Therefore, we call them feasible region. Now, throughout this lesson, we will use this term feasible region. Okay, now this is some additional information. This is a convex polygon, so that I will explain like this. Just now I told you that our solution should be somewhere in this shaded area. Our solution should be somewhere in this shaded area. So that means it can be any point inside this figure. Now my question, how many points inside in this figure? How many coordinates, how many points inside in this figure? Can someone tell me how many points are there in this figure? How many coordinates?
5 coordinates.
5 means I think you mean these corner points, but I am asking inside. Just think and tell me.
Three coordinate.
Fifteen coordinates.
So any other answers?
Fifteen coordinates, sir.
So how did you find that 15?
X is y and x is y 1 and x is x 1 2 3 4 5 6 7 0.7.
Okay, okay. So why can't we take x is equal to 0.5? You can take x is equal to 0.6, 0.7. X is equal to 0 0.1, 0 0.11, 0 0.111. Why can't we take like that?
We can.
We can.
No, sir.
Then how many points are there?
And y greater than 0.
Yeah, greater than 0. X is equal to 1.1. That is greater than 0. Greater than
But,
0 means positive.
But coordinate 0 1 is not greater than 0.
0.01 is greater than 0. Greater than 0 means positive. But if we take minus 0.01, that is negative. We cannot
yeah.
take. So then how many points we can have here?
To 27.
Infinity points.
What?
27.
How can you find 27? So what was the other answer? I heard some other answers.
Infinity points, no?
Now, can you speak little bit loudly?
So infinity points.
Yes, we can find any number of points. Now, for example, you can start from x is equal to 0 0.1, 0 0.11, 0 0.12. Like that, we cannot count it. There are infinite number of points because there is no condition that x and y should be integers. The only condition is that x, y should be positive. Okay, so therefore, we can have any number of points here. So infinite. Now the problem is that when there are infinite number of points, out of those infinite number of points, how can we find the point that is corresponding to the solution? Now solution is also coordinate 1 point, 2, 1, 3, 1, 3, 4, like that. There should be some coordinate for x and y. Now, out of these infinite number of points, how can we find? Now the basic idea of this graphical method is we have the objective function. Now for this particular example, objective function is 2x plus 4y. Objective function is 2x plus 4y. Now we have the feasible region. From this feasible region, we have to take points of the feasible region and substitute in this objective function. When we substitute all the points, we will have a list of values for the objective function. From the list, we have to select maximum value and we have to select the x and y points corresponding to this maximum value. So that is the method of graphical method. For feasible region, we find all the points and we substitute in this objective function value. Then we will have a list of values. So out of this list, we will select the maximum value and we will take the corresponding x and y value. So that is the case. Now the problem here that when we have infinite number of points in the region, we cannot do this practically. When we have infinite number of figures, we cannot do this practically. And there is a theorem that when this figure, when this feasible region is a convex polygon, now for the time being, just remember this word, I will explain that later. When this figure is a convex polygon, the solution exists at one of the corner point of the feasible region. The solution exists at one of the corner points of the feasible region. That is a theorem that we can use. Now convex polygon, that one I will explain in a later. I want to draw and show you what are the types of convex figures. but usually you will get all figures convex, so you don't have to worry about that one in this module. But we want to focus on this theorem. When we have convex polygon, the optimal solution exists at one of the corner points of the feasible region. Now here we know that we have corner points. Now this one is a corner point. This is a corner point, and this one is a corner point. This is another corner point, and this is another corner point. So we have 1, 2, 3, 4, and 5 corner points in this figure. Now, since we know that the solution exists at one of the corner points, so we know that the solution is one out of these 5 points. Now the problem is simplified. Earlier, we don't know this theorem. We thought that we have to substitute all the points into objective function and find the maximum value. So that is not practical. But because of this theorem, the problem is simplified. Now we have to substitute only these 5 points and find the maximum value. Okay, so that is the use of this theorem. Now we have to find the coordinates of these corner points 0, 0, 0. This is 0, and this last one 8, 0, and other two also we have to find. So if we draw the graph correctly on the graph sheet, you can measure and find. If not, we have to find some technique. Otherwise, if you draw the graph correctly into a correct scale on the graph sheet, you can measure the distances and find the point. So by using whatever the method which you find the point, there are only 5 coordinates. You can substitute in the objective function. Then you can find the maximum point, because our question is now a maximization problem. Okay, so the feasible region has a corner points, so that we know that. Then we need to find the coordinates of each corner point according to our theorem. Then substitute the coordinates of each corner point in the objective find corresponding objective function values. Then select the coordinates corresponding to the maximum objective function value. So this is the method that I was just explaining. Now, if you do that for this problem, these are the 5 corner points. Let's say A, B, C. So this one O, that is the origin. So usually 0, 0 points we denote by O. A, B, C, D. So we have 5 corner points. We have to find the coordinates of each corner point. So this is the feasible region. Now you can see. Now the solution exists at either this O, D, C, B, O, A. That means we have to find the coordinates of these points O, A, B, C, and D. In fact, we know some points. We know this point D, we know this point A, and we know this point A, but we still don't know B and C. Okay. Coordinates of O, A, and D are known. Then we want to find the coordinates of B and C. Okay, as I explained, if this is drawn in a graph sheet accurately, we can measure and find. If not, what we can do is, if you want to find the point of C, what is the method that you can use? If you want to find the coordinate of C, what is the method that you can use? Can you tell me just from your O-level mathematics knowledge, how you can find the coordinate of this point C? Anyone has any idea? how you can find the coordinates of this point C, for example. Okay, yeah, for B, I will take B, this is more clear. So how you can find this point B without taking the distance, without measuring in the graph sheet, how you can find this B? Any idea? So it is very simple mathematics. How you can find point B?
සමීකරණ දෙක සමගාමීව විසඳලා
Yes, that is the method. So we for this point B, so point B is there because of these two lines. There are two lines, so intersection of two lines. For these two lines, we know the equations of these two lines. Then we know the equations of these two lines. If you solve these two equations as simultaneous equations, the point of intersection is the solution to those two equations. Then you can find point B. In a similar way, you can find point C also. So you can take this equation and you can take the other equation and solve them simultaneously. Then from the solution, you will get the point of this intersection. Like that, you can find B and C. Now we know that OAD, then we can find point B and C also. Then after doing that, we will have all 5 points. So that is explained. So you can find the coordinates of B and C, then the coordinate of corner point of the feasible region. So I have done it for this example. 0, 0, 8, 0, and B, C, and D also have coordinates. Then these are the coordinates of the corner points. Then what we can do is, we have the objective function 2x plus 4y. We have to substitute all these points into objective function and find the values. So we have set of values. Then what can we do is that we want to find the maximum Z value. So we have a list of values here for Z. Once we substitute these coordinates into objective function, we have a list of value. Out of this value, we have to find the maximum one, that is 19, we can see. So this is the maximum Z. If it is the maximum Z, then we have to find corresponding X and Y value. So this C is the point that gives us the maximum Z. C is the point that gives us the maximum Z. So the value should be X equal 4.5 and Y is equal to 2.5. So that is for X and Y that gives us the maximum Z. So all the other value, any other value in any other coordinate in the feasible region definitely give you a lesser value than 19. If you want, you can check. There are infinite number of points in the feasible region. If you take any value other than this 4.5 and 2.5, that definitely give you a value less than 19. If you want, you can check. So this is the only value that gives you the maximum value for Z. Therefore, we say that this is the optimal solution. We say that this is the optimal solution. Therefore, the optimal solution for this problem is X is equal to 4.5 and Y is equal to 2.5. Okay. For this particular problem. Now the problem is given here. The problem is maximize this function subject to subjected to these constraints. And what we have done was we have drawn all these constraints in the same graph plane, and we found the feasible region. Then there is a theorem that the solution exists at one of the corner points of the feasible region. Therefore, we had to find the coordinates of all the corner points of the feasible region. For this particular example, we had 5 corner points. There are cases that we have 3 corner points. There are cases that we have 4 corner points. But here, for this particular example, we had 5 corner points. So we found all the coordinates of the corner points, 5 corner points, and then substituted in the objective function. Then when we substitute, we'll have a set of values. Out of those values, we have to find the maximum value. So once we get the maximum value, we can refer to the coordinate that is corresponding to the maximum value. So that is the solution to this problem if you substitute any other value in the feasible region. Out of the feasible region, that may be different, but if you find any value out of the feasible region that does not satisfy the problem constraint. So if you take any other value other than this 4.5 and 2.5 inside the feasible region and substitute in the objective function, definitely you will get a value less than 90. So that is why this solution is called the optimal solution. That means the solution of x and y that gives the maximum objective function value. Okay, so this is the method of using that to find the optimal solution to a problem. But the problem is that we can use this method only for the problems with 2 variables, because we have only x and y in the graph sheet. If it is 3 variables, we cannot use the graphical method. Okay, so any question at any point from this example?
සර් එතකොට මේකේ මැක්සිමම් අගය වෙන්නේ 19 කියන එකද?
ඔව්, ඔය constraint ටික ඇතුලේ ගන්න පුළුවන් maximum value එක 19. එතකොට අපිට එන්නේ xy කියන උත්තරෙන් මේ constraint ඔක්කොම satisfy කරන්න ඕනේ, නැත්නම් මේක වැරදි. For example, if you substitute x equal 4.5 and 2.5 here, so you can check. Now check whether all the constraints are satisfied here or not.
ඉන්ෆිනිට් පොයින්ට්ස් වලින් කෝනර් පොයින්ට්ස්ම සිලෙක්ට් කරන්න මේ මොකක්ද රීසන් එක කිව්වේ?
Yahan, so what is your question? Yahan මොකක්ද වගේ මට පැහැදිලි නෑ.
සර් ඉන්ෆිනිට් පොයින්ට්ස් වලින් අර කාඩසියන් ප්ලේන් එකේ ඉන්ෆිනිට් පොයින්ට්ස් වලින් අර මේ පොලිගන් එකේ කෝනර් පොයින්ට්ස්ම කන්සිඩර් කරන්න රීසන් එක මොකක්ද
ඔව්,
කිව්වේ?
ඒකට තියරම් එකක් තියෙනවා. ඒ තියරම් එක අනුව තමයි ඒක ඇවිල්ලා තියෙන්නේ. ඒ තියරම් එක තියෙන්නේ මම මෙතන එක්ස්ප්ලেইন කරා වගේ කෝණ පොරක් ගන්න පුළුවන් මේ ෆිගර් එක කන්වෙක්ස් ෆිගර් එකක් නම කන්වෙක්ස් ෆිගර් එකක් ගැන worry වෙන්න එපා. මම කන්වෙක්ස් ෆිගර් එකක් කියන්නේ මොකක්ද කියලා පස්සේ explain කරන්නම්. ඒ වුණාට ඔයගොල්ලන්ට මේ මොඩියුල් එකේ basic linear programming problems වල අනිවාර්යෙන් එන්නේ convex polygon එකක්. ඒ නිසා ඒක ගැන worry වෙන්න එපා. ඒ theorem එකක් establish කරලා තියෙනවා research කරලා අනිවාර්යෙන් solution එක තියෙන්නේ මේ කෝණ point වලින් එකක විතරයි කියලා. ඒක නිසා තමයි අපි කෝණ points විතරක් හොයන්නේ. And the solution
මේ
is
පොඩු අර constraint තුනටම මේ අගයන් දැම්මම ඒක මේ ඕකේ වෙන්න ඕනේ නේද?
ඔව් constraint තුනම satisfy කරන්න ඕන.
ඒ වුණාට
So
සර්
you can see this.
equalization පහම නේ.
මොකද්ද?
අඩුයි හෝ සමානයි හරියන්නේ.
අඩුයි හෝ සමානයිනේ මේ values ටික බලන්න x 3y වුණාම 12 එන්නේ. එතකොට ඒක satisfied. x 2y 11.5 that is less than 16.
Okay.
5x 9y exactly 45. Still all are satisfied. Okay, any other questions? Okay, so you can try our second example, the tables and chair example with the graphical method. So I will post it as an assignment in the Google Classroom, then you can do it and send me the solution. Okay, because there's not that for today because of the disturb that we had due to power failure. So what I will do is I will stop the class with this example for today. Then I will send you one exercise to the Google Classroom. You can do it and check whether you can find the solution. Okay, so if you do not have any other question, we stop the class for today. I think we are not going to have the class next week because you will get the study leave for your semester 1 examination. So your head of the department will communicate with you. So if not, we will have the class as usual. If there is a study leave after the examination, we will continue with this module. Okay, so we'll stop the class for today with this example.